Hello, in this video I'm going to go through 4 more challenging questions on surds. So before you try these questions, you need to make sure that you have fully understood how to rationalise the denominator, because it's going to come up in all of these questions. This form of question that I've got in these 3 examples is a form of question that comes up quite a lot in AQA GCSE at the level 9. So these are worth being able to do confidently. Okay. So I'm going to suggest you pause the video, have a go at these 4 questions, and then when you think you've done what you can, play the video and I'll go through the process. Okay, so first of all, I'm going to go through this one here. We've been asked to rationalise the denominator, and this we have to just follow a standard process, but you just have to be careful with every stage of the way that you don't get stuck. So looking at the denominator, we can see it's not rational because we have a surd there, and we've got an addition going on. Whenever you have an addition or a subtraction with these, you're going to have to do something a little bit more complicated. You're going to have to use the difference of 2 squares in order to get this to an integer. So using the difference of 2 squares, what I'm going to be doing is I'm going to times the top and the bottom of the fraction by the complement of 2 plus root 2, which is 2 minus root 2. So it looks exactly the same, but just with a minus in the middle rather than a plus. So I'm going to times the top by 2 minus root 2. And I'm going to times the top by 2 minus root 2. And I'm putting brackets around it to show that I'm multiplying by the entire thing. So I'm going to put brackets on these as well. And the next thing I need to do is expand and simplify. So if I expand and simplify the top step by step, 2 root 2 times 2 is 4 root 2. 2 root 2 times root 2, 2 times root 4, or 2, is going to come up as 4. So I'm going to get negative 4 for that. You can take off the working out for the multiplication to the side and do it step by step. You don't have to do it in your head. Then I'm going to do 4 times 2, which is 8, and 4 times minus root 2, which is minus 4 root 2. And then on the bottom, it's difference of 2 squares. You can expand it step by step, but the quick way of doing it is thinking 2 squared is 4, root 2 squared is 2, so I've got 4 minus 2 there. If I now simplify the top and simplify the bottom, hopefully you'll notice that on the top, the 4 root 2's cancel because we've got plus 4 root 2 and minus 4 root 2, so they cancel out, and then I've got minus 4 plus 8, which is 4. 4 minus 2 on the bottom is 2. 4 divided by 2 is 2. So the answer to this is actually 2. Okay. Next up, for these sorts of questions, what you want to do is you want to take each bit one by one and simplify it. Once you've simplified each bit, you then worry about doing the adding and the subtracting afterwards. Because this process is a little bit longer, I'm going to do it on a whiteboard and then transfer my final answers afterwards. If you got this in a GCSE paper, you would be getting 3 or 4 marks, and you typically get a mark for each part that you correctly do. So I'm going to start by doing the root 20. Because I've been told in the question that I'm aiming for k root 5, I'm hoping that each part is going to have a root 5 in it. So that kind of acts as a little bit of a hint to help me. Now, if I simplify root 20, I can break that into root 4 times root 5, which is 2 root 5. So the first bit, root 20, goes to 2 root 5. For the second bit, I've got a denominator that isn't rational, so I'm going to be wanting to rationalise that first of all. So 20 over root 5. If I times top and bottom by root 5, sorry, it's a 20 there, isn't it? I'll have 20 root 5 over 5. This can be divided because 20 and 5 are both multiples of 5, so that can become a 4 and a 1. So that comes out as 4 root 5. So my second bit simplifies to 4 root 5. And now I just have to do my final third bit. I've got root 30 over root 6. Now, when you have a surd over a surd, a root over a root, you can write it as the square root of the one thing divided by the other. 30 divided by 6 is 5, so it's the same as root 5. So then here, this last bit is a root 5. So I'm doing 2 root 5 plus 4 root 5 minus root 5. And then I just have to work through what that comes out as. So 2 root 5s plus 4 root 5s is 6 root 5s. Take away root 5, gets us 5 root 5. I've got it in the form that I was asked for in the question. I've just got k as 5. So I'm now finished and can move on. If you had this in a GCSE exam, you would want to have all of this working out clearly shown as well, so that you've got all the stages of your process. Okay. I'm now going to go through this one up here, and just the same as before, I'm going to go through each bit one by one and work out what that's equivalent to, and then put them together as I go. So I'm aiming for k root 3, so I'm going to have a root 3 involved in each part. So first of all, 18 over root 3. I need to rationalise this denominator. I'm going to times top and bottom by root 3, and I'll get 18 root 3 over 3. The 18 and the 3 cancel. That goes to a 6 and a 1. So I get 6 root 3 over 1, or 6 root 3. So this one here is 6 root 3. Okay, on to the next one. I've got an improper fraction, a mixed number here, 6 3/4. I'm going to change that to an improper fraction. Okay, so 6 3/4 is the same as 24 quarters plus 3/4, or 27 quarters. Now, root of 27 over 4 can be broken up into root 27 over root 4. Now, root 4 is actually 2. Okay, so if you've got a square number on the bottom, it's quite a nice thing to do this, because then you end up with a whole number on the bottom. So I've got root 27 over 2. And I now want to simplify the root 27. Root 27 is root 9 times root 3. And root 9 is 3. So I've got 3 root 3 over 2, or 1.5 root 3s. Because 3 over 2, 3 halves is 1.5. So my second one comes as 1.5 root 3s, or 1.5 root 3s. You write it however makes most sense for you. Okay. I'm going to have to remove some of the working out in order to be able to do the next one. Just give me a sec. Okay, so I'm going to clear this in order to be able to do the root of 3 over 4. The process I'm going to go through for this one is very similar to the one I did just a moment ago. So the square root of 3/4 is the same as root 3 over root 4. The square root of 4 is 2, so I've got root 3 over 2, or half of a root 3, or 0.5 root 3, however you prefer to think about it. So this one here is half of a root 3. Okay, now I've done each bit step by step. I'm now going to put them together. I've got 6 root 3s, take 1.5 root 3s. Together that makes me 4.5 root 3s. And then I have to add half a root 3, and that gets me 5 root 3s. So that's my final answer, and k is equal to 5. Okay, final one. For this one, again, I'm going to go through it step by step, but I'm expecting to get a root 2 for each part of the answer. I'm going to do each bit one by one and then put it all together. So 6 over root 2, rationalise the denominator by timesing by root 2, top and bottom. 6 root 2 over 2. 6 and the 2 cancel and become a 3 and a 1. So I've got 3 root 2 over 1, or 3 root 2. Okay, next up, I've got to simplify root 32. Now, you can do this more than one way, but I'm looking for the biggest square number that is a factor of 32, and the biggest square factor of 32 is 16. So root 16 times root 2, or 4 root 2. Okay, so that's that bit done. And then finally, I've got to think about the root 2 cubed. Now, root 2 cubed is root 2 times root 2 times root 2. I can put that together by just timesing them. So root 2 times root 2 times root 2 is root 8. And that can then be broken up into root 4 times root 2, or 2 root 2, simplifying the surd. Some of you might be confident getting that quicker by thinking root 2 times root 2 is 2. Okay, whichever way you prefer to think about it. So we've got 3 root 2 plus 4 root 2, which is 7 root 2. Take away 2 root 2, and we end up with a final answer of 5 root 2. So k is 5. K won't always be 5, just in this case, the 3 examples I've gone for happen to have K as 5. Okay. So if you do get one of these questions in your GCSE, I would strongly encourage you to just make a start and have a go. A lot of people see this incredibly long sum with loads and loads of roots in it and are put off trying, but it's really, really worth having a go, because even if you can't do the whole thing, you might be able to tackle one part of it, like this bit here or this bit here. And if you start to write down some of your method for the examiner, you will start to pick up some marks, because it tends to be 1 mark for each bit and then 1 mark for putting it together at the end. So don't be put off, really do try and have a go with it, even if you're not 100% sure.